I found it just incredibly stimulating, and I hope you did as well. So let me just try and do a really quick summary, and I'm going to do two things. I'm going to try and summarize the content, and I'm going to try and summarize the overall messages. So let me begin with the content, and most of you were here all day, so have heard this. We had 4 terrific technical sessions. The first of them was about the innovations that led to the internet and the World Wide Web. And there were 3 talks. The first was about the combination of technologies that enabled us to Google. And what Alfred Spector said I think is really important, and that is that Google didn't occur through spontaneous generation in a garage in Palo Alto. Right? So Google is, first of all, a lot of Google-specific and Google folks-specific innovation, but also a lot of really outstanding engineering together of a set of innovations that were in some sense available for anyone to use, but the Google folks figured out how to use them to really change the world. So it drew upon a collection of advances, and I'll say more about this later. Then we heard about the transformation being brought about by cloud computing, moving applications from your desktop into the infrastructure. What it does is give you access to unlimited computational power and unlimited amounts of data, really arbitrary amounts of computation and data, and it's going to change healthcare, education, science, and productivity. Finally, in this session, we heard about human computation. So that's harnessing hundreds of millions of people, literally, through games on the web to solve problems, like digitizing 35 million words a day with reCAPTCHA. So the theme there is hybrid systems, humans plus computation in the loop together, solving problems together that neither could solve by themselves, and that's really revolutionary. Then we had a session on foundations. Foundations are the sort of core work in our field that everybody draws upon. So we heard from Barbara about algorithms for building scalable, reliable systems, Google and Microsoft and Yahoo scale systems, Amazon scale systems. Then we heard about machine learning, a great list of concrete applications of machine learning, which in many ways is a technology that goes back 40 years. But machine learning for spam filtering, language translation, right? Google allows dual language search in 40 pairs of languages, right? For postal address recognition, for medical diagnosis, the smart grid, just a technology that has made enormous recent strides based on a long foundation, and it's changing the world in many ways now. Finally, global information network. So this explosion of data leads to information systems that both catalog and reflect social structures and social trends. And those systems become reflections of social structures and social trends and tools for investigating and understanding them. So again, a real revolution and a clear interdisciplinary revolution. Right, then we heard about the transformation of the sciences via computation. Larry Smarr told us about the path from high-performance computing to high-performance networks to computational science that focuses on the data and discovery of data through machine learning and data mining. We heard about visualization in medicine, which at some level was, from the MD's point of view, an intrusive curiosity 10 or 15 years ago, and it's an indispensable tool today. We heard about the Human Genome Project, where computer science advances really lie at the heart of the Human Genome Project and the future of this correlation of your genotype and your phenotype, which is totally going to change human health and medicine and the pharmaceutical industry. So this is driven by advances in computing. These desktop gene sequencing machines, Gene told us, have the power of the entire Celera infrastructure of just 10 years ago that really cracked the human genome with shotgun sequencing. And by the way, those desktop gene sequencing machines generate about a terabyte of data a day. The Sloan Digital Sky Survey, which is a triumph of data-oriented science, took a decade to accumulate 15 terabytes of data, right? So these gene sequencing machines generate that much every 2 weeks, and modern science projects like the Large-Scale Synaptic Telescope do more or less 4 Sloan Digital Sky Surveys every day. So this volume of data we have to deal with is just extraordinary. Okay, then we heard about computing everywhere. So we heard about environmental sensing. We heard about the transformation of media, desktop publishing, digital audio, digital photography, digital video. We heard about robotics. What we heard there is that the future is robots operating in unstructured environments, And to a limited extent, although large in numbers, the future is here today. There are 4 million home cleaning robots. Consumer Reports has some qualms about it, but the fact is they're hugely valuable and hugely widely used. There are 10,000 military ground robots in Iraq and Afghanistan. And what Rodney pointed out is that the US leads today in these robots that act in unstructured environments, but we once led in manufacturing robotics. Robots in fixed, predictable environments, and we let that lead slip away. So the question is, what's the future of robotics in unstructured environments? And that's a good lead into sort of the messages of the day. So here's my sort of bullet points of messages of the day. One is computing really has changed the world, our lives, our economy. Secondly, that it's a rich and complicated ecosystem that's made America the world leader. That's an ecosystem that involves the federal government, university researchers and educators, industry researchers and educators, and research funders and product developers. Okay, so we are the world leader, and this complex ecology has made us the world leader. Research has laid the foundation. Federally supported, often university-based research can be traced at the roots of every billion-dollar sector of today's information technology industry. It takes 10 or 15 years to get from original breakthrough to billion-dollar industry. This has been really well studied. What that means is you need patience. There's no such thing as just-in-time research. Often, products, innovations, are created by synthesizing a set of advances that exist and maybe making 1 or 2 additional advances that glue them together. Okay? So this is unlike other fields. In biomedicine, a single patent may hold the clue, the key to a blockbuster drug. In information technology, it's often a very clever engineering assemblage of existing research results. Okay? And it means that old ideas often obtain new life, right, or a second life. Perhaps because new applications come along, perhaps because the hardware gets to the point to make things practical. There have been a lot of machine learning breakthroughs recently, but it's built on ideas that are 40 years old. There have been a lot of search breakthroughs recently, but it traces its roots back to the information retrieval work of Salton at Cornell, again, 40 years ago. Today, there are a large number of components available to be assembled. If you think about speech recognition or handwriting recognition, these have been goals of our field since the beginning for 50 years, and they're really becoming practical today. And they're available. If you want to do something that requires speech or requires handwriting, you can more or less get that as a component, which gives you something really significant to build upon. I'm going to interrupt myself for just a minute because Congressman Lipinski has just arrived. He's the subcommittee chair for Research and Science Education, and one of the original sponsors of this meeting, and I'd like to ask him to join us and say just a few words. I want to thank you so much for being here, sir.
Thank you. I saw many of you at lunch today, but it's very good to be here with you. We have, next week, we're going to have the 90D bill that we are working on in the House Science and Technology Committee, which is led by Chairman Bart Gordon, who's been a very good champion of computing. It's really important that we all get together and we talk about what can be done at the federal level, work out what we can do to help with computing. Computing is central to so much that we have, all the advances that we have seen. Those things I talked about at lunch today, saying 25 years ago when I started college, how simple, even as a mechanical engineer, I only had 2 computing classes. And now computing is, you see it everywhere, but unfortunately, a lot of people don't even know it's there. They don't know that it underlies all these great advances, technological advances we've been able to make. So I'm just very happy to be here. Thank you for the invitation. Happy to co-sponsor this symposium. And I just want to thank you for all the work that you are doing, work that is often unsung. People don't realize what it is that underlies all the great things that we have today that we really could not live without. So I encourage you to keep up the good work. It's important that technology transfer also is something critical, bringing all from the basic computing, bring that through to industry creating all these technological products and services that we have available today. So thank you once again. I'll let you continue and continue good work. Thank you.
So there are a number of members of Congress who have a long-standing understanding of engineering and science, research, and of computer science and engineering research and its contributions. And you've just heard from one of them. So thank you so much for all you've done for us and for all you've done for the nation. We appreciate it enormously. At lunch, he was describing how, as a mechanical engineering undergraduate 25 years ago, there were a couple of places where he could get access to batch processing, and that was sort of computing. And then he arrived in Congress and they immediately handed him a BlackBerry. So times have indeed changed. Thank you so much. So this old idea of attaining new life is important, returning to where I was. And I think many breakthroughs do have this second life. An opportunity to use them comes up. Computational power or the advance of computing and algorithms makes enough progress that you can really take advantage of things in ways that you couldn't take advantage of them before. And I think handwriting and speech are great examples of things we've been trying to do for decades, and they're finally ready for prime time today. Something I've noted before is often products are created by synthesizing many advances. So again, unlike biomedicine. So our work is often motivated by a strategic goal, not always, but often. But our track record for understanding what the actual impact, the biggest impact of our work is going to be, is surprisingly bad. We discussed email this morning, there are many others. I think many times we're pursuing a strategic objective, but it turns out not to have been the right one. Our technology, our advances are usable for something else. We're not very good at guessing what the biggest impact of our innovations is going to be. So what this means is that serendipity plays a huge role, and that any attempt to decide what research is important versus unimportant is probably not going to pan out, right? Because if you look back at what the real importance was of networking or time sharing or you name it, it was often different than the one that we anticipated at the time. We had a reason for doing it, but it didn't turn out to be what was the most important reason. We heard that much of the work today is interdisciplinary and multidisciplinary. So open, collaborative, interdisciplinary research is important, but we also heard that there needs to be a portfolio, right? That people need to have the latitude and the support to work on the core of the discipline. Because again, you can't anticipate always what the applications are going to be. And we see time and time again that this foundational research has played an instrumental role in building something of huge practical value 10 or 15 or 20 years later. The track record, and Larry Smarr said this and I repeated him, is that in this country we have an amazing ecosystem and infrastructure that leads to breakthroughs. And we've been extremely successful. Pat Hanrahan said we can do the most amazing things now. And I think that's really the case. We can do amazing things. These can be our golden years because there are tremendous people working in the field. Lots of the young ones are here today. As an older person in the field, I sort of look at you as my retirement plan. That looks pretty good because the amount of innovation that was in the room today was phenomenal. We heard about all kinds of very recent advances. We talked about a lot of components that are available to draw upon. And as the Congressman just said, computing is central to everyone's lives and to our economy. So I found this to be a hugely uplifting day. I want to thank all of the attendees, all the participants, and I want to encourage everyone to go off hugely enthusiastic about what we can contribute to the nation and to the world. We're poised like no other field to change the world. Thanks for being here.